Now, in this lecture, we trace the curve y whole times of x square plus 4a square, which is equal to 8a cube. We have to trace the curve y times of x square plus 4a square, which is equal to 8a cube. Let us try to simplify it. So it can be written as x square y plus 4a square y, which is equal to 8a cube. Or we can write down y is equal to 8a cube upon x square plus 4a square. Let us give it equation number 1. Now, for tracing this curve, we need to check the following points. The point number 1 is about symmetry. Since the power of x is even, just look here. If we see the equation, the power of x is x present only in the first term and its power is even. So the curve is symmetric about y-axis. Now, since the power of y is odd over here, so it is not symmetric about y, x-axis. Right. Similarly, there is no any other symmetry. Now we know that there are 6 types of symmetries. So it is only symmetric about y-axis. About the origin. Now just look here. If you see this second part of the equation, this is variable term because x and y both are present. This is also variable term because y is present. But just see the right hand side of the given curve equation. It is 8a cube, which is not a variable, which is absolute constant. So since absolute constant 8a cube present in the given curve, so the curve does not pass through the origin. Now, what is intersection with coordinate axis? So let us put y equal to 0 in 1. We get, if we put x equal to 0, what will happen? Just look here. If we put this is 0, so 8a cube upon infinity. So something upon infinity is something upon 0 is infinity, x is square, x is 0. So uh, sorry, y is 0, y is 0. So if we put y equal to 0, the value of x is infinity. Similarly, if we put x equal to 0 in 1, we are getting 8a cube. What is that? This will become 0 and 8a cube 8a cube upon 4a square. So a square will cancel. 4 1 ja, 4 2 ja. So we are getting 2a. So y is equal to 2a. So we have only the curve intersect at the coordinate axis only at 0 to a. What is 0 to a? So suppose this is the x-axis. So this is 0 0 and this is the point 0 to a. So coordinate this curve intersect at this point 0 to a. Let us go ahead. Hence curve meets coordinate axis only at 0 to a. Now we have to find the tangent at 0 to a because this curve does not pass through origin, right? So we are not able to get the tangent at origin, but it passes through 0 to a. So let us try to find out the tangent at this point. So what is the procedure for that? We know that we have to find the derivative. That derivative is called the tangent. So we have the equation number 1, x square y plus 4a square y, which is equal to 8a cube. So let us differentiating with respect to x. We get the first function x square, derivative of y is dy dx, plus derivative of x square is 2x into y plus 4a square, derivative of y is equal to dy dx, which is equal to 0 because this is constant sum, to derivative of constant is 0. Now if we simplify it, we can transpose this 2xy to right hand side, and x square plus 4a square times of dy dx. So dy dx is what? It is minus 2xy upon x square plus 4a square. Now let us put x equal to 0 and y equal to 2a. X equal to 0 and y equal to 2a. So numerator will become 0 and denominator will become 4a square. So we are getting dy dx at 0 to a, which gives us 0. So what it means? It means that tangent at 0 to a is perpendicular to y-axis and parallel to x-axis. It means that if we are getting dy dx equal to 0, so tangent at this point is parallel to x-axis. Means this is the point 0 to a, 0 to a. So at that point, tangent will be parallel to x-axis. Tangent will be parallel to x-axis. So, and so how to trace the curve? Now, so there will be, and now this is what we can write down like this. This is the tangent at origin. And we have already seen that the curve is symmetric about y-axis. So now we are getting the same type of branches in the left hand side of this y-axis as well as right hand side of this y-axis. Let us try to find out the asymptotes. So the first asymptotes parallel to x-axis, here highest power of, what is the highest power of x? It is x square. This is x square and its coefficient is y. So equating y equal to 0, we are getting the asymptotes parallel to x-axis, which is nothing but x-axis itself is an asymptotes parallel to x-axis. And similarly, the highest power of y is y, right? Means 1, and whose coefficient is 4a square, which is absolute constant, so cannot be equating to 0. So there is no asymptotes parallel to y-axis. Let us go to the, since we have one parallel asymptotes. Okay, hence asymptotes parallel to y-axis. Okay, yeah, we have x square plus 4a square. This whole thing is the coefficient of y, so equating it equal to 0. So we are if we transfer 4a square to right hand side, we are getting x square equal to minus 4a square. So we are getting the imaginary asymptote. So no need to find out the imaginary asymptotes, or there is no meaning to trace the curve if we are getting the imaginary asymptotes. Now there is no oblique asymptotes because we have already got the parallel asymptotes parallel to x-axis. Now, reason of absence. From equation number 1, we have y equal to 8a cube upon x square plus 4a square. So if you put x equal to 2a over here, what we are getting? Y equal to a. If you put x equal to 2a, then y equal to a, and put x equal to minus 2a, then y equal to also a. Hence, 2aa and minus 2aa are points on the curves. Okay, can you let me describe it? Let us first discuss about this thing. Since x equal to 0 is an asymptotes, so curve does not exist for y is less than 0. Also, the curve does not exist for y greater than 2a because 0 to a is the tangent at that point. Hence, the approximate shape of the curve is given by. Okay, let us discuss one by one again over here. So the first point is origin. This is 0, 0, 0, 0. Second point we are getting is 0 to a. Now, what is the tangent at 0 to a? This is the tangent at 0 to a, right? This is tangent. And similarly, what is asymptotes? This is asymptotes. This one is the asymptotes. So curve will never exceed. Curve will touch. This curve is finite distance. This what is the distance from this to this point? It is 2a. So curve is finite distance from the uh, given straight line, but it will never intersect this curve. It will intersect at it will touches at infinities. Therefore, it is called asymptotes. So definitely the curve lying between x equal to y equal to 0, this y equal to 0 to this y equal to 2a. There is no any part for which y is greater than 2a, because this is a tangent. If it will be greater than, then this curve will cut the tangent at that line, so that will not be tangent. Similarly, this is asymptotes, so the curve will not intersect, or the value of y should not be less than 0. And again, the curve is symmetric about which axis? It is symmetric about y-axis. So we are getting the, what is the getting the shape in the left hand side of the y-axis? We are getting the same type of curve in the right hand side of the given curve. So this is the approximate shape of the given curve. Thank you.